Good afternoon to everyone, and thank you for giving me the opportunity of presenting this work. As you can see, I made little changes in the title, giving it the title of Resync Bees and Trees, a project for an art museum device using a near-infrared light. But before speaking about the project, I shall introduce myself and those who have collaborated, who are collaborating in this project. I'm Marco Innocenti, a PhD candidate at the University of Pantin-Sorbonne, Paris, and a researcher at Bee Futures. My PhD research is funded by an industrial agreement between my doctoral school and the company Bee Futures. I want to thank Professor Olga Kisseleva, which is an artist and professor, and the coordinator of the Eden project, with which I will present later. Guillaume, co-founder and the chief design officer at Bee Futures, and Christophe, founder and CEO of Bee Future. Well, starting from the company, Bee Futures, it's a Franco-Norwegian biotechnology beekeeping company founded in 2019. And in addition to hive-based biomonitoring solutions, including sensors, camera, artificial intelligence, the company is also developing innovative ways of caring for bees without chemicals, but leaning on new technology and electronic technologies. The mission is to combine biotechnology, data science, and 30 years of beekeeping practices to meet today's challenges in bees' health. This study originates from a collaboration between Bee Futures and the Eden project, coordinated, as I said, by Olga Kisseleva, which uses new technology to protect trees and enhance their links to each other on both local and the global scales. Olga Kisseleva has worked with a huge team of scientists from all over the world, from the Rift Valley to the Amazon forest, from Japan to New Zealand, in order to create also this web of trees. And this project won in 2020 the STARS Prize, awarded every year by the European Commission. STARS stands for Science, Technology, and Arts. Well, starting from this collaboration, this project will create a museum installation which will be able to aims to present, to communicate to people the existing symbiosis between pollinators and vegetation, and also to suggest new ways to improve, to enhance this symbiotical communication, this symbiotical process, facing, of course, environmental challenges, today's environmental challenges. As we all know, maybe I don't have to present that, but the process that relates bees and trees consists in the fact that bees find nutrients, pollen, and nectars on trees, especially in their flowers, whereas on the other side, trees finding bees a mean to propagate their pollen from flower to flower for reproducing themselves. So neither species, nor bees nor trees, would easily survive without the other one, and without, of course, the correct functioning of this symbiotic relationship. Not surprisingly, as I said, this symbiosis has been deeply disrupted by human-induced climate change. So in recent years, there have been a huge mismatch, often be a mismatch between flowering period on trees and the activity of bees. This asynchrony depends on both long-term and short-term changes in climate. So we can think for the long-term changes, we can think of seasonal temperatures which varies and so we can think of bees that exit from hives too earlier or too late in the year, and or blossoming trees which don't find bees to propagate their pollen, or in the short-term changes we can find sudden waves of frost or heat which prevent bees from exit from their hive and from enjoying the flowering and fulfilling their task, their pollination task. So what we need, therefore, is a technology that can repair this asynchrony on both these time scales. So the concept here of this project is to select two biotechnological devices, pre-existing devices, on the basis of their similarities, thereby trying to cross-pollinate technologies through aesthetic criteria. We have found, in fact, that many art and science projects, especially in starts, managed to create a technological system from different technology that otherwise would have been put into contact with each other. So we will assemble these technologies into an innovative system able to synchronize bees and trees activities again, and we will present it to the public in the form of an art and science installation. The first technology, we have selected is the near-infrared light treatment developed by Bee Futures. Professor Glenn Jeffrey from the University College of London studies how age-related eye diseases can be cured through red light treatment, since this light can recharge cells' batteries, namely, of course, mitochondria. With the help of Professor Jeffrey, Bee Futures has developed a red light treatment not just for bees in vitro, but also for bees for infield beehives, which enhances honeybees' resistance and resilience against pesticides and environmental stressors. On the other hand, there are LED grow lights, which provide plants with the red and blue lights they need to grow, to blossom. And depending on the type of plant, exposure to this light, to this red or blue light in different times of the day, can accelerate or delay the flowering period. And this practice is already used in greenhouses. So using these lights, we could synchronize the plants blossoming and the bees foraging again. To quickly describe this scheme, we can say that through LED glow lights flowering, through grow lights, flowering can be brought forward or delayed depending on the intensity of swarm activity. So, for example, if we find a really a beehive which is excited, which is already in action, in foraging plants, foraging, searching for food around in the field around the hive, we can accelerate the flowering of trees. And this swarm activity can be approximately described as the volume of its hum. This can be effective on the long-term changes in seasonal cycles. On the other hand, for the most abrupt changes in climate, instead, we can use red light treatments on these. In fact, when some flowers buds appear, when buds appear on the branches of trees, we can start a treatment session that can prepare the swarm to tackle any climatic stress in the following days quickly enough to enjoy the upcoming blossoming and to fulfill their pollination task. Thereby, we can tackle this asynchrony between bees and trees activity on different time scales, be it a matter of months or of days. To speak about the installation, we will show the prototype of this technological system as a museum installation. Here, a beehive equipped with the red light treatment will be connected to a little greenhouse with growing lights, which can suggest the use of this system in wider greenhouses. So the beehive, which will be, of course, empty of bees, will reproduce the buzz sound of a real hive, which will be transmitted to the greenhouse in the form of light and intensity. By regulating the intensity of the grow light proportionally to the volume of the hum. Of course, after being developed through tests and protocols, maybe this technology won't lean on this simple proportion, which I doubt could work as such. But the point here, the point of this installation, is not to present people ready to use technology, but rather to present first the symbiotical system, the symbiotical connection between trees and bees, but also the fact that this project, this prototype stems from the collaboration between an art project as a Eden project and a technological company, and that together an art project and high-tech companies can help each other to cope with new problems related to climate change, to human-induced climate change. So in this first phase, the proportional link between the buzz volume and the light intensity will be therefore explicitly symbolic. We have the ambition through this museum installation of proposing an immersive space for people to reimagine the future of humankind and technology inside nature. We can imagine visitors immersing themselves and wandering in the sound of the hum of a beehive, or in the red and blue lights emitted by the installation. However, it is important to highlight and notice that this installation can also be adapted for educational purposes in way more museums, including with technology, with devices for educational purposes that could include interactive features, for example, VR and AR devices. Thank you very much for the attention, and of course, do not hesitate to contact me with to this address, and to pose to ask some question if you have. I will answer. I will be glad to answer to any question. Thank you.